Control and regulation engineering is essential in a wide range of mechanical, electrical, and chemical systems, where the design and analysis of controllers optimize performance and stability in various processes. The Computer-Controlled Modular Control and Regulation Unit, RYC-T, designed by EDIBON, consists of the RYC as the essential base unit, to which multiple options can be added according to user needs, providing a practical and versatile environment for teaching this discipline. Each unit in this series allows students to clearly and effectively understand the principles of modeling, analysis, and design of control systems, adapting to different study scenarios. Thanks to its configurable design, the RYC-T series enables the simulation and regulation of first and second-order systems, the implementation of PID controllers and lead lag compensators, as well as the analysis of system responses to disturbances and compensations, offering a comprehensive learning experience in control and regulation. In this video, we present the PID Control and Regulation of an Inverted Pendulum Unit, RYC-PI, designed by EDIBON, which allows the experimental study of one of the most representative classical problems in automatic control, stabilizing a pendulum in the vertical position. This unit makes it possible to analyze how controlling the linear position of a moving cart can maintain the equilibrium of an inherently unstable system, providing a real environment to apply and deeply understand PID control theory. The RYC-PI is built on a robust metallic structure that integrates the main sensors and actuators required to study the system. The cart movement is generated by a direct current motor powered at 12 volts, capable of reaching speeds of up to 10,000 revolutions per minute, and coupled to a transmission system that enables precise control of the cart's linear displacement along a guide of approximately 1 meter in length. The moving cart acts as the displacement platform for the inverted pendulum. This assembly allows the analysis of the complex dynamic interactions between the linear motion of the cart and the angular stability of the pendulum. To ensure accurate measurement of the process variables, the unit incorporates several sensors. A speed sensor with tachometer output allows the measurement of the motor speed, while a linear position sensor with an output of up to 10 volts enables precise determination of the cart position along the system. In addition, the pendulum is equipped with an angle sensor, which allows real-time analysis of variations in the pendulum's angular position and its response to the applied control actions. This unit comes with the complete supervision, control, and data acquisition system from EDIBON, which includes a control interface and the necessary software for real-time analysis and interaction with all process parameters, as well as for managing the collected data for subsequent analysis and processing. The Computer-Controlled Teaching Unit for the Study of Regulation and Control, RYC, is an essential tool for students and instructors in the field of control and automation systems. It enables hands-on experimentation with fundamental control concepts, allowing the analysis of first and second-order systems in both the time and frequency domains, providing a detailed understanding of their behavior. With the RYC, users can explore different system responses such as step, ramp, and sinusoidal inputs, as well as study the operation of lead lag compensators. Additionally, the unit allows for an in-depth study of PID controller structure and tuning, both in open-loop and closed-loop configurations, applying methods such as mathematical tuning, experimental tuning, and the Ziegler-Nichols method. If we also consider the practical exercises available with the RYC-PI, it is possible to explore different control levels within the system, beginning with the characterization of a speed control system and the study of PID control applied to the motor. The unit also allows the analysis of a position control system and the implementation of PID control for the cart movement. Finally, it is possible to address the PID control of the inverted pendulum position, studying how the cart displacement can be used to maintain the pendulum in its vertical equilibrium. These exercises provide students with a practical understanding of control systems and PID controller tuning in real dynamic systems. Thanks to the incredible capabilities of the SCADA software developed by EDIBON, when connected to the unit, you can easily monitor any changes in values in real time. From the comfort of the software interface, you can observe differences in the hardware and analyze all data using intuitive graphs. With advanced features such as real-time control, data monitoring, and acquisition of hundreds of data points per second, get ready to take your research or training experience to the next level with our state-of-the-art SCADA software from EDIBON. All our equipment is completely safe and can have expansions added in the future if you wish to include additional features. Thank you for watching. We hope it has been helpful. See you in the next EDIBON video.